Alright, so I'm going to ask you to factor. I just kept something up there nice and clean. Okay, so we have x to the 2n power plus 11x to the n power plus 24. The main thing I'm doing on this one right here is to see if you understand powers. Okay, if I change this, instead of being a 2n power, if I was to change that right up there to a 12n power, what you have to realize is, okay, when I factor this, okay, what is my first term going to be?
X.
It can't be just x and x, because x times x is x squared, and I got to get either, like I had before, 2n or 12n. So I guess my question goes back to, what are the power properties? If I have 3 squared times 3 to the 5th, well, let's, or x squared times x to the 5th, what do I get? X to the 7th or x to the 10th?
X to the 7th.
You sure?
Yeah.
Okay. This right here is x times x, and this right here is x times x times x, and how many x's do I have then?
7.
Okay, this is x to the 7th, because we essentially add our exponents together. When you multiply them, okay, is when you have a power to a power, this is x to the 10th, because what I basically have is I have 5 x squareds, okay, that I'm multiplying, okay, together. That's what that means, and 5 of them are x to the 10th. So my problem right over here stemmed back to, if I have this as x to the 2n power, what times what gives me 2n power? Okay, if this is an n power, then that's an n power. Okay, now tomorrow on your quiz, I probably won't leave this as just a 1 right here. Okay, tomorrow on your quiz, I'll probably put this as a 12 here, and this is a 48 right over here. Okay, and what I'm looking for is, do you know how to, okay, do all the shortcuts? Because if you don't know the shortcuts, something that has this probably has about 12 to 18 combinations that you'd have to test. But of those 12 to 18 combinations tomorrow, I guarantee only one of them is logical. Okay? What I mean by logical here is, if I had here 12x and 1x here, should I put 48 here and 1 there? No, that's not logical, because that's like really huge. Okay? Now, back to my original problem here. I got a little bit off task here. We're talking about the test. Okay, so we're here at x to the 2n power plus 11x to the n plus 24. What factors of 24 are going to give us this? Well, if you're not good at the factors, and I would, again, tomorrow recommend you use the half method, because I'm not going to use nice numbers like 24. Okay, it may be something like 512. Okay, and if you do that, you should always use this half method, and that lists all the factors out. And then the factors are nice and easy to see in the middle. 1 and 24, 2 and 12, 4 and 6, 3 and 8. Now, of those factors right there, we got to see which ones give us 11x to the n power. And you're right. 8 gives us 8x to the n. 3 gives us 3x to the n. Okay, so when we're done, I have 8 x's to the n power. I have 3 x's to the n power. I get a total of 11 x's to the n power. I just need to make sure those fixed. Someone had questions. Did I answer them? We're good? Okay. We all good at example number 1? All I have is 4. Okay. But the problems today are not going to be one-steppers. Okay. You're going to be able to have to find, okay, more than one process. We have 8 ways to factor quadratics, or 8 ways to factor, I should say. Okay, and you're going to have to see a problem like this, okay, and determine, ooh, what do I do first? Okay, go ahead and write it down. Okay, here, and I'll kind of walk around here and see, what do you think you're going to do first? Add, you just count. I have 8 of these x ends and 3 of these x ends. So I have a total of 11 of these x ends. Right. You may have an idea, what should I do first on this? I mean, it looks pretty scary.
Factor out.
Factor, you could factor a GCF out of this. It would be factoring a binomial GCF. I think some of us would be a little calmer if we did one thing here first, though. Yeah, substitute. I think a lot of us like to, come up here and say, oh, let's substitute W in for that x plus 1. And I think that's a safe bet. This turns into 8W to the 5th minus 26W cubed.
Now, can we possibly do the greatest common factor?
That's fine. I said you can do that. Yeah. Okay. Now I chose to use substitution because I think it'll be a little bit better from here on out. Because I'm looking at this, okay, and I'm seeing, well, what's your number 1 rule that you should always do whenever you're in trouble?
Common.
Yeah, GCF. Don't start doing anything. I mean, I just use substitution up here to make it look easier. That's the only reason substitution was there. It didn't do anything. It just kind of eased my mind of, whoa, this looks complicated. Now, I want to see what's my greatest common factor. That's always step 1. 2W, correct. Okay? Now, before I answer your question here, Sydney, the one thing I have a comment of is this is what some of you do when you factor a GCF out. You factor it out and you think it's dividing into this, and you throw it away. When you factor it out, it is a factor. Okay, it comes out. Yes, when you reduce this right up here, you are dividing by 2W, so you do get, okay, what's left over here is 4W, okay, to the 4th. You get 13W squared, and you get 9, okay, right there. Okay, but I didn't throw a 2W away. Okay, it factored out as a GCF. Okay, so any question?
I have to write it at GCF to the side.
I like to write it over here just to the fact that I'm reminding myself there. That's there.
So
So
we have to.
I say you do not. Yeah. Okay. No, I mean it's more. I would say no on this, but I'd say more a yes on this 24 little factors over here on the side. Just from the fact of when it gets bigger, it's nice to have those factors in. All right, are we all done?
No.
Okay, if you got to this point tomorrow and said you're done, okay, think twice. It's too good to be true. Okay, all you did is you really didn't know how to do anything but factor a GCF out. Okay, so on your quiz, I'm going to have usually more than one step. Okay, so the next thing is what's up? What do I do here?
The trinomial thing.
Okay, trinomial. I'm going to factor this trinomial. It kind of looks like 2 squareds right here. There's a 4 and there's a 9. It's not a difference of 2 squareds because I get a middle term, but maybe it's a perfect square trinomial. So if it was a perfect square trinomial, that means I'd have 2W, 2W, and 3, and 3 right there. And my insides and my outsides give me... Maybe not.
No.
Okay. I thought I was getting so excited there for a while. And I thought for sure.
If only it was 12.
If only it was, but it wasn't. Okay? So we don't get 12. Okay? We had to get 13. Maybe I could come over here and I could try here. I got the 9 and the 1 and the 3 and 3. Well, I have the 2W and the 2W down. maybe I should change these to the 9 and the 1. Does that help me out?
Well, the problem is that you got like 4W like.
Oh yeah, I should probably put a squared there and a squared there. Yeah.
No.
That still doesn't help by just putting that squared there? No, the 9 here gives me 18W squared and 2W. So I should just switch the 9 and the 1 around. Take the 1 and put it here and take.
That's not gonna do you anything.
Oh, okay. You're probably right with the 2 and 2. Okay, so what do you think? You can't factor it. We're done. Problem's easy. All right, so still we got 4 and 1. Okay, so we'll come down here and I'll put 4W squared. Okay, and W squared right here. Don't forget, I'm telling you, there's going to be a handful of you that throw the GCF away.
If you don't.
Okay? So we have 4W squared and a W squared, well, 9 and 1. Yeah, that might work. If I put, do I want the 9 there though? No, that one gives me 36. So this is where I'm telling you tomorrow, common sense says I probably don't need 36 when I'm clear up here at 13. Okay, so I'm going to take and put the 9 here. Okay, and that's going to give me the 1 here. Does that one work with the 9 and the 1 there?
Yes.
Okay, and I want a negative 13. So if this is 9W squared and this right here is 4W squared, that means they both have to be negative. Alright. Pretty good, huh?
Oh.
That's when you sit back, you smile, and I'm so good. Nah. Why not, Andrea? Why don't they like me being none?
You have to factor out the 4W minus 9 and
The-
the W squared minus 1.
Oh, difference of two squares. Okay, so you got to realize that this a squared minus b squared there, that's a perfect square, that's a perfect square, and it's a difference of them. If it's a plus there, we're good. Okay, but because it's a minus, we can do this a minus b times our a plus b thing right here. Okay, so I'm going to factor this down into 2w minus 3 and 2w plus 3. And I'm going to have w minus 1 and w plus 1.
And don't forget to
The thing out in front. What's the thing?
The greatest
2W.
common factor.
Oh, the GCF! And finally, phew, now I'm all done. Linda, no, I'm not. Why aren't I done? That can't factor any further. What's wrong, Avinia?
You have to put the chicken back there.
All right, don't get so excited. You got to the end, and don't forget. Okay, we know W was x plus 1. Okay, so I gotta come up here and I gotta put x plus 1 in here. Okay, I gotta put x plus 1 there. Okay, so I'm gonna substitute in. Okay, x plus 1. Okay, and all of those spots. Okay, right there. So we have 2 times 2 minus 3 times 2 times that. I guess this minus 1 and that plus 1. There we go. Got it all substituted in there. Now we're done, Daniel, right? No, we're not. I guess that's not
Pause
right.
for a second. I gotta get caught up.
You gotta get caught up. You got so caught up in my difference of squares and my GCF. And I'm going so fast. I'm getting so excited though. I just want to get to the end. Some of you, I know, are just getting so distracted that I have a hat on. That you can't
Yeah,
focus.
it is very
Good badge.
distracting.
Now the badges, Well, luckily, I think Drew will be watching this out there, and he won't get so distracted, but because of the
Standing
fact
up
that
there
I
with
have
your hand in your pocket too, so it
my hand, so I look like I'm,
Yeah.
big and tough. And,
Farmer.
Yeah, farmer. There we go, both of them there, like that.
No,
Okay.
just the one.
Just one. That's
Yep.
fine. Okay. Why am I not done? Thought I was all done.
Solve it.
Because you
Oh, that's all, but I need to simplify, right? Simplify it. Okay, so this part right out here, I'm fine if you actually leave that as 2 times x plus 1. Okay, but okay, I want to see, when I'm done, I'm going to have 5 factors here. I want to see them all. This one right here is going to be 2x plus 2 minus 3. This is 2x plus 2 plus 3. This is x plus 0. I guess you really don't have to write x plus 0 there, but... Alright, I know some of you did this in your head. You probably don't have to do that last step because some of you were combining the 2 and the negative 3 together and got minus 1. You combine the 2 and the 3 together there and got 5. Some of you didn't write that x minus or plus 0. So how many factors did I end up with?
5.
And it's amazing that because this was a fifth power, okay, that's how many roots you're always going to have.
Really?
This problem, you're always going to have, now they're not always going to be real numbers. This problem right here has 5 real answers. And some of you got to stop and think when I'm saying real answers. I'm not saying, make-believe ones. It's the real number system. Like an integer, okay, or a rational number, or an irrational number. They have 5 of those. Okay, a little bit, okay, like next week. Okay, we're going to start talking about, imaginary numbers. Okay, numbers that are not real. Okay, they're pretty easy to work with. Okay, they are. I don't know. Do I? Imaginary. Imaginary. Well, they're just not on a real number system. You can't count
What
them.
number system are they on?
The imaginary number system.
Like, is it? But then they're not really numbers.
They are. They're imaginary. They're not real.
Like, give us an example. Like.
Okay. Square root of negative 4.
Oh.
Oh.
What's the square root of negative 4? It does in an imaginary world. It's 2i.
Huh?
2 imaginary.
Yeah, it's imaginary numbers. Because the square root of negative 1, can you ever do a square root of a negative number?
No.
So what they do is they say, okay, anytime that you get a square root of a negative number, we're going to substitute in the word I for it. Okay, so that you can now work with the real number. Okay? Because we have to talk about how the imaginary numbers are not solutions of your x-intercepts. Okay, so they won't be x-intercepts, but they will be zeros.
How is this going to help you when you go and do your job? Oh my
Well,
gosh.
you're gonna be a writer anyway, so then this never helps anyway, right? Well, somebody's always gonna say, well, I'll never use this, so I'm not gonna lie to you. You may or may not use this, but you know what? Whatever you go into, I'd like to have you as broad as possible.
What job besides?
The imaginaries? You talk about it in engineering.
Oh, okay.
You have to deal with imaginary stuff. All right. Example 3 of 4. Here we go. This example right here is the person on a test that sees this one. I could see someone solving this one and taking 10 minutes to do a 2-minute problem. Okay? But it's solvable that way. But then you come to the end of the test and you say, did you guys ever run a test or quiz? Okay. And you say, what do I do now? Well, you need to realize that this problem up here is not solved by foiling this all out, distributing what I probably forget to do, distribute that negative to everything, then combine it all together and then factor it out. That's not how I would do it. Could you do it that way?
You should.
Yes.
But it's a 10-minute problem versus a 2-minute problem. What I see right up here is a substitution problem where I see a difference of 2 squares. I'm calling W the 5x minus 2. I'm calling this z this x plus 3. Now how I know to do this, it doesn't matter. Whenever I see a minus with 2 different squareds, whether or not it's simple, like this, or it's fancy, like that. Okay, this is all a perfect square right here of 3 times xy squared. Oops. Okay? This is a perfect square of 4a to the 4th, b to the 5th. Okay? They're perfect squares. Well, that's what I saw right up here. I see a perfect square here of w minus z, w plus z. And am I done? I mean, I said 2 minutes, and that would have took me 30 seconds.
No.
What's the only thing left? Yeah.
Plug it in.
Plug it in. Oh, she's back to singing again. All right, so we're going to plug into the first one. My first w is the 5x minus 2. Okay, my second w that I have is x plus 3. Okay, we're going to subtract those. And I'm going to do the same thing right over here to that whole quantity right there. Oh, the amazing thing that I can do with technology these days. It doesn't even fit in there, so I'll just shrink it down and put it in there. But instead of subtracting them, what do I have to do in the second one? Add them. I just got down a 2-minute problem in a minute because I can clum. Am I done now?
No. No.
You are? So it did take you 2 minutes. Okay, I'm going to get this part right here slide. Whoa, that's kind of cool. Let's get all of that out of here for a second. Okay, now I do see this part right over here. This is an easy one. Since this is a plus, those give me 6x, and that gives me 1. Okay, and this one right over here, you got to be a little bit more careful because this is subtracting both of those. So it's a minus of both of those right there. It's kind of like some change in subtraction to addition, subtract the both 2. So that gives me 4x, and those give me minus 2 minutes. Verse foiling all that out, foiling that out. Okay, combining them together. Okay, not forgetting to distribute that minus sign, and then trying to factor it all out. Maybe take you 10 minutes out. Okay?
Maybe less.
Maybe less. Okay. We got one example left. How are we doing so far on a scale of 1 to 5? Well, this last one's the easy one out of all of them. But when I turn it, you're going to say, oh my goodness, it looks hard. But this, this one is probably the hard one of all of them, right there. This one right here looks hard, but now that I showed you, it's easy, right?
Right.
And the same thing here. This one right here looks hard, but it's probably the easiest of all. Whoa. Dang. This one's easy. Some of you are still looking at me like I still can't concentrate with that hat. Maybe that's why I don't ever wear a hat. You never take me seriously, man. You jerk.
No.
You don't take me seriously, no. Sometimes. You never know, because I'm always giving everybody so much. Maybe just Aaron a hard time, but sometimes I must do. Maybe Cindy sometimes give her a hard time. Being you the other day, I gave her a hard time. I made her cry, so I'm not doing it anymore. Just kidding. You guys looked at me like, for real? You did? No, I'm messing with you.
I saw you in parade yesterday.
You did? Yeah, I had her drive by myself, but all my other coaches got in the one in front of me, so I looked pretty important in that nice fancy car. That was a pretty nice car, though.
What car were you in?
Yeah. I was in the Camaro convertible.
Oh, okay.
Yeah, it's pretty nice. All right, so what do you guys think about this problem right up here? Well, for one, this one looks different. Do you guys see any powers up here?
No.
No. So I don't see any of the, factoring out a difference of squares. I don't see any perfect trinomials. Okay, I don't even, do you guys even see one common binomial in the whole thing?
No.
Or even one common GCF in the whole thing?
No.
So anybody have any ideas? Yeah?
You guys think that 8xy minus 1
We could try this group, because we've done that before. But does that help me when I group it there? No. But I like where you're going with that, because instead of grouping it there, whoops, Okay, the one thing you guys got to know, does it matter what order you put these things in when you're adding them?
No.
So could I have put those together first? Okay, so let's just rewrite it. Minus 15ab plus 6ay. Why did I decide to group those two together?
A.
They have an a. Actually, they have more than an a.
They have 15.
They got the 3 there. Okay, and then it leaves me with these two right here. So I got the 8xy minus 20bx. So I kind of grouped those together. All right, what did we decide that first one was?
Negative 3a.
Negative 3a. All right.
Well, actually, does it really matter if you take the negative out since there's no...
It doesn't because there's no power, but I want to do like second and fourth. They said the same thing.
Okay.
They said negative 3a. So I'm going to ride with it. Okay, and negative 3a, and that gives us, that's nice, 5b right here. And this is minus 2y. Okay, so that's not too bad. Okay, next one right over here, I'm going to factor out positive 4x. Is that what you guys got? Oh man, I don't want it. This is 2y though. If I wanted to use grouping, what's going to have to be true about these sets of parentheses? They got to be the same, so I screwed up.
Just take negative 4x out.
Well, I could have done that, but I don't like that because then I'm going to have two negatives here. What I really should have done is, because this has no powers, I know I always say factor out a negative if possible, and this really is not a leading coefficient because there's no, greatest power in this. So I'm really just going to take out a positive 3a, which helps me because that's now a negative 5b and a positive 2y. Okay, so here I have, I'm just going to change the order here so you can see what we have in parentheses. Do we have the same thing in parentheses now? Okay, so now I'm just going to factor out a binomial of 2y minus 5b. Now those of you that don't understand what I'm going to do here, if you want to just substitute in a variable for what I have in blue, that's fine. Okay, what I'm going to do here though is I'm going to factor out 2y minus 5b because they both have that in common. And then what's left in this one is 3a. What's left in this one is positive 4x.
It's like, I don't understand the, you don't, like, you can just take out external parentheses.
There was no squares in the first place.
No, but I mean, like... never mind.
This one that doesn't apply by what you're talking about. Okay. Do I FOIL this all together again? Where would I end up if I FOILed it all together again? Right back up in the beginning. So some of you got to realize when I ask the factor, you're done when you're down here. Do I have to do any substituting back in or anything like that? No, I'm just done. Okay, like I said, this was actually one of the easier ones that looked very fun. Okay, so where do we at on a scale of 1 to 5? 5, we're doing good. 1, I kicked you in the butt and you're still down. Alright, only Aaron's done. Alright, homework for tonight. Okay, now it will be kind of hard to take my whiteboard home from you, so I did record this, so I will post this if you don't get through number 8 here in the next, you got 25 minutes, okay, to do these 8 problems. I am going to post my answers to the website. Now,
So,
I did not, this used to be a worksheet, but I didn't copy all the problems down. So there's 15 problems on the worksheet I'm going to post to the website. I think if you want to check your answers, which I hope you do, just try to find each one on the worksheet somewhere. The answers are there. Okay? Now, because tomorrow's quiz has part of section 2.3 in it, I have this part right here in blue from the book. Okay, so about 8 problems that are the advanced ones, and then about 10 problems from the book that talk about, finding the x-intercepts and, finding the zeros, okay, creating the intercept form, okay, things like that. Now, this part in green, I deleted it from 4th hour. Forgot to tell 2nd hour before they left that I didn't want them to do it, okay? But I like you guys better than 2nd hour. And I should say that I'm recording this right now, so and hear me. It's kind of like your favorite child. You tell them your favorite child, but you never tell the other one you told them.
You like us better, so you're giving us more homework?
So I will take this off, okay, right here, okay, because I don't think if you work well, time's not going to allow you to get through that. Okay, I'm just going to stick it on to tomorrow's assignment, so you're going to do it sometime. But, yeah, either you have it this weekend or you have it tonight.
Alex,
You do it tonight at 11 o'clock.
pretty much.
All right. All right, any questions here about what we're doing? All right, everybody say goodbye to Drew.
Bye, Drew!
He's been watching at home all the time. So, Drew.
Hi, Drew.